open source projects. And that's where I got paired with Elisa and Raymond, who were interested in that project proposal. And so I'll let them take it away from here, but basically today we'll get to hear about what they learned and built over the summer.
Yeah, thanks for the intro. I'll just tell you guys a little bit about myself first. So my name's Raymond. I go to a place called Make School. They're in SF. So that was before COVID. Now everyone's mostly remote. They still have like an on-campus, a limited on-campus thing, but yeah, so that's me. I'm about to graduate actually tomorrow. So get to start up the job search, grind some weak code. Yeah. But first of all, doing all this. Oh, thank you, Aaron. But first of all, this presentation and yeah.
Hello, everybody. My name is Elisa. I'm from Houston, Texas, actually. So yeah, I'm a computer science and a math junior at the University of Houston. And yeah, I had some experience with Unity, with camera and stuff. And I really like this project. I actually picked it first because I wanted to work with data visualizations. Kind of just like to set the base to later study some computer vision, some more advanced stuff. But yeah, I'm really excited to be here today with you guys.
Let me just share my screen. All right, so the project we worked on for the past 12 weeks is a library called Hubble. Since you guys are all on Chris' team, you might know about it already, but in summary, it's just a camera for your data visualizations. But first, let's talk about how I started. So my background, this is actually a bit of a different direction for me because my background is in machine learning and doing some back-end web. So in the Code Labs process, we actually got to pick, I believe, 5 choices. And this was like my second choice. My first choice would have been working on a project with Netflix. It would have been like ambient flicks where they would, gather information about your weather, the weather, your Twitter feed, stuff like that. In order to give you Netflix recommendations. So my project on that would have been, the idea that I had was to gather every frame in a movie and average the colors and figure out if that's like a warm color palette or a colder color palette. So, a warm color palette, you could recommend that when it's hot, like, oh, you might want to watch this based on the weather. Or I might have gone into like the Twitter API and like done some NLP work to figure out like what sort of keywords would match what they've been saying versus what Netflix could recommend. So that's more my ballpark. So this, the reason I chose this is because I really wanted to level up as a software engineer, and I realized, just how big of a code base that this was. So I thought it'd be like great practice for when I first started, my first software engineering job. Just to get some good practice ramping up. And just to give you guys an idea of where I first started, this was my pre-work. So I actually did this before the internship started, but this was just kind of my my experience. Like I knew a little bit about React. I'd taken a class, so this was just me playing around with like Deck.gl and the various layers. I think I did earthquakes. It was earthquake data. It's some weekend in July, I want to say. But yeah, it was just me, reading documentation, playing around, experimenting, looking into like loaders, Deck, Hubble, or Kepler, just kind of like seeing how this all interacted with each other. Yeah, and then, after that, it went into some documentation stuff, which I'm sure, the Deck, Hubble, and like Kepler teams, they all appreciate. They just kind of, while I'm learning about that documentation, I'll like, fix broken links or like, hey, this isn't clear, or I believe I actually made like a whole tutorial just based on some things that Chris had wanted. Just like rendering tips, like explaining the workflow of how, here's a visualization that you exported. What do you do with it? How can you make it look nicer? And yeah, there's like associated images with this, but it still needs to be pushed onto the Hubble documentations. Yeah, and that's probably, those are like some of the major milestones for me to where I am today, where I know like the parts of the code base that we're working on, and I'll actually be able to, you know, answer like a couple of questions in the Slack group or things like that. And like, yeah, I also know like where to get unblocked, you know, that way I'm not always having to bug Chris. And you know, I believe these are your slides, Elisa.
Yep. So about my background, I had some experience with Unity 3D, so I kind of knew, like, had some exposure to the camera and how that works. Actually, that helped me a lot later. I'm gonna talk about some of that later. So I had experience with web development and software testing, and I wanted to know some more about data visualizations. Like I said before, like kind of like set the basis to start learning some of computer vision in the future. And I didn't know any React when I started. So I had to, like, in 2 weeks, I don't know still, but like kind of like in 2 weeks, I had to learn a lot and go through the tutorial. And Chris asked us to do like a project, like kind of a trivia. I have it. Isn't that next one? Okay. So kind of like a trivia thing. So I can learn about the states and props and components and a bunch of stuff. But like I kind of had to do that like in 2 days or something. So it was really hard to do. But yeah, that was like my first. Yeah, and I had to also start learning the documentation, reading a lot of the GIF on Hubble, and I didn't knew at first. I was kind of lost about the relationship between all those libraries. But then, yeah, with time, it helped that. But yeah, that was my first steps, kind of like in the process. So yeah, go back to Raymond.
Yeah, so since we did have a small group, we could probably just ask, you know, ask the group. So I was curious, normally, you know, if I was still in San Francisco, then I would go to like a React meetup or like a data visualization meetup and just kind of see how people use these two libraries, these two bigger libraries, Deck and Kepler. But, you know, since we're a small group, how do you guys use Deck and Kepler? So anyone that wants to share?
Yeah, so from my end, all my work with it is through Chris actually. So thanks, Chris. But I primarily use this internal tool that we call Voyager that basically uses this stuff on the back end.
Oh man, it's all based off of telescope names, telescope and spaceships.
It's literally just a wrapper around Kepler. It is Kepler.
Oh, okay.
Yeah. And so we're all on the system simulation team at Elevate. And so I do a lot of the analysis of our simulation outputs. So that looking at different markets and looking at things like, where do we want to place skyports in our markets? Where are the demand hotspots in those markets? Things like that. So obviously looking at that geospatially, being able to put like a heat map on an actual map and being able to pick out actual different locations and stuff is super useful. So that's the main way that I use it.
That's cool. It kind of sounds like almost a mix between data visualization and possibly business intelligence.
Yep, that's basically where I sit.
That's cool. Anyone else? How do you guys use Deck and Kepler?
So I'm actually like, now I'm working in Elevate, but before that I used to work in the city ops down in Chile. So basically Kepler was the tool that you would use eventually like once a week for any query that you end up doing. Like, for example, like you want to see where the people are like doing something, or you want to analyze how a big event actually worked, or like how the airports are working, like all that stuff was based on Kepler. Back in the days, it wasn't like what it is now. I joined over like 3 years ago, and I can see like how things has been progressing. And the one that I really love to see is actually what you are implementing, which is the recording. I asked for this like a year ago to Chris, and I'm happy that now we will see the light out of it.
Yeah, that's good then. You'll get to see the things that we've done, and you'll just a little spoiler, we did integrate something into Kepler. It's not pushed to production yet, but you know, you'll see. About Jonah or Aaron, would you like to share?
Sorry, my connection's a little bit terrible, so if you can hear me, then let me know.
Yeah, I can hear you.
Yeah, I basically helped Chris and Jalen build all of the visuals that they want through an automated process. So like when it comes to like creating new what are they called, new layers.
Oh, okay. So
or
like
if there's a specific task, specific visual that they want to view on the map, then I help them out there, and creating templates for Kepler visuals, and automatically sending data through to create, I guess, the complete map. And,
potentially like some loaders GL in there. I'm not too familiar with like Uber's internal.
Oh no, I just use Kepler. I mainly use the Python Kepler bindings.
Yeah, so
yeah,
this diverse user group here where you have some power users that use Kepler directly as an analysis tool. Then you've also got Aaron and I who use it for automation, and we use the Python bindings quite regularly. Pablo also uses it, like he's mentioned when he's used it, he's shown me how he's done that, and it's through like embedding Kepler as a library within another app. So like it's all in the browser, but you're able to do the data query and then populate that data into a map. So it's kind of like a SQL query plus Kepler, if that makes sense.
Yeah,
so it's showing all those different, a lot of variety of ways to use these applications. Yeah,
I'm kind of imagining it's like, I'm trying to remember if it was Deck or Kepler that had like a IPython via Jupyter Notebooks integration. I'm kind of imagining something like that. Yeah,
they both do now. It's pretty wild.
Oh, they both do. Okay.
Yeah.
All right, that's cool. So our project was essentially we put to allow people to create cinematic visualizations, and the way that we aim to do that was to integrate it with Kepler. So there's still like some process there, but you'll get to see all that we've accomplished in the 12 weeks. So let's talk a little bit about how it fits into the ecosystem, because it's a gigantic WebGL, I don't know, web. I saw the diagram earlier, and Chris and I were talking about like, how do we incorporate this? And I'm like, this was like the best that I could do to like not make it super confusing. But yeah, essentially the way that Hubble works, in the background, there's some loaders elements and some Luma elements that get fed into Hubble. And from there, it's kind of like a developer library. So you can either plug it into Deck, but also the thing that we're working on is more a user-facing aspect, where eventually on Kepler, you'll just have like a default little export button where you'll be able to export your own, you'll be able to like define camera angles. And the way I word it is kind of like a mix between data visualization and cinematography. So you can get like these fancy pans or like, zooms and, So let's talk about what we accomplished. Before it might have looked something like this, where you're just like showing a static map and, it's okay. That's definitely a lot of work went into Kepler, but, if you want to like show off to the executives or people who control the money, essentially, then you might want something like these animations, which Chris has lovingly crafted, but you'd be able to make something like this within the components that we've worked on. I believe this was from the Elevate Summit. Is that right? Just based on, yeah. And not quite to this level where you can like do the transitions and stuff, but that's kind of the tutorials that I indicated would allow you to do, like how to export it and how to do post-processing steps, stuff like that. So yeah, let's talk about what we made. So on the right here, this is kind of the mock-up that we were originally sent. Just like, hey, you know, this is the idea that I had, and this was our first introduction to what the integration would have looked like. So, you know, over the things that I worked on mostly is the UI elements and connecting things to the Redux store and making a lot of stuff in React. So, you know, in as you guys will soon see in the Kepler app that we made, there's now like an export button, which will lead you to a modal like this, which will, you know, give some camera angles that you want or some qualities, like some timing stuff. Yeah, just like a bunch of settings. Yeah, so some of the challenges though, like, you know, Elisa and I already mentioned, is just how large this code base was. I think the format of Code Labs might struggle a bit just because ramping up, you know, even for interns usually takes like a month or so, and we couldn't really have that. So our ramp up process had to be like, you know, half of that. We spent like a week or two just like, and the rest was just learn as you go, pretty much. But it was cool being able to see like different, just how many hands this has touched, you know, with it being open source. It's like a large library. There's like multiple different engineering practices and coding paradigms that it was very cool to look at the code base. But yeah, so like I was saying, the difficulties were that it's a large code base, but also something that, you know, school doesn't generally prepare you for is how to deal with like these technologies. So like I said, I'd done, you know, a little bit of React, a little bit of Redux, but you know, the idea of scaling it to however many tens of thousands, hundreds of thousands users that Kepler and Deck have, that's something that I had no idea how to do. And likewise, that also led to unfamiliar paradigms, because there was like, for example, the way that Kepler, they do their Redux store is completely different. They abstract certain things that I just had no idea, I've never seen before. And yeah, so the last one, I had worked on like, you know, small groups and where we would have like a Git master or like a team lead that we'd have to go through to push to production. But, you know, there's a couple more steps in this case. I have to go through Chris, have him look at it. And then in this case, we have to talk with the main contributors who I understand were previously Uber, they're Uber engineers. So all of that, just that's, you know, the steps that we have to do just to push something to production. And, you know, they don't work at Uber anymore, so they're on a completely different timetable. Yeah, so I'm about to show you the demos, but I really want to emphasize the difference. So the first one that I'll show you it'll be the Hubble app. You know, have like the components, but it's going to be based off of the Kepler library. So I don't have as much fine control of things as I wanted in comparison to the second one, where I just integrated it directly into the app. And you'll see I could do some cool things that I wasn't able to do before. But yeah, so basically, for those of you who don't know, the difference between the Kepler app and how I integrate it is that there's something called a Redux store, which basically it just kind of like, you know, let's just say this is the one I did with the Hubble one. It was using states. So if I wanted to travel between these nodes, I would have to pass, you know, states in between each one. Whereas with the Kepler store, I could just like, it's kind of like a global thing. I could just refer to it at any point in the life cycle that I wanted. Yeah, so let's take a look at those demos. So the first one here, this is the one I was talking about. It's using React states. And when you click that export button, then, ooh, that is broken. I don't know why. I had this working earlier. That's just typical of presentations, isn't it? Literally, like you checked it 5 minutes before, but something broke that and you didn't even touch anything. The Kepler integration one should work though. Let's try that. So we just kind of like did world flights was kind of our like hello world. It was the smallest sample data set, and we've just kind of been experimenting with that. But yeah, I understand there's another different type of, I want to say it's called like the timeline that we've got to work on after this.
Yeah, the time filter. So in Kepler, what we started with was the two different kinds of animated data. There's the trips one, where you can kind of see the flights moving around or cars on the ground. And the other is the time filter, which we had previously used at the 2018 Elevate Summit when we went and progressed through 24 hours of movement data. Each one of those hour buckets was using that time filter to animate through that. We decided to focus on the trips feature first, and then we'll later be able to extend it to the time one as well.
I am not sure why. I'll just show you guys the Kepler one. So this is the main difference. This is what would be a potential integration into the actual Kepler app. So like I was saying, this is going to use Redux stores. So versus like this one was just using states. So it's not quite the way that Kepler wants to do it, but this is what I'm going to push to the Hubble repo as an example. Just be like, hey, this is how it's going to be potentially integrated in the future. Yeah, so as you guys can see, there's like a little export button down here. And when you click on it, then the thing that I couldn't do with those states is, I don't know if you guys saw it, but all the points, they disappeared. So that's something that I'm pretty proud of. You know, it makes rendering a lot more efficient because you don't literally have to load in 2 different GeoJSON points, trips layers, et cetera, et cetera. And there's like functionality to all of these. So I could do kind of like an orbit like that, or like we have various options right now. They're predefined. And yeah, it's so that's like what we built.
So as Raymond mentioned, I'll be talking about some of the things that we accomplished and roadblocks that we had that were a lot, and also demoing a little. So, but I'll be showing mainly the features that I helped to develop and possible plans for those features, like things that I think would be cool to have, like nice. So first, some background. So GIF and Mapbox, they're often, they're used together to create these beautiful geospatial visualizations, and they were used together to build the Kepler. But it wasn't until the idea of using Hubble.gl, which handles the 3D animations and the video rendering, to create this project, right? So, so the idea, I'm just reiterating. They asked to create a simple video export feature of the trips layer first. And so that trips layer was shipped in 2019 by Sean, I think. So let me go. Yeah. So why the trips layer? So a trips layer has some waypoints, which they have inside coordinates and timestamps. So it's easy to work with. And I mean, we talked about the idea of having other layers in the future, like implement this feature of exporting to extend it to the other layers. So yeah, we're not experts in yet there, but we'll get there. So coming back to the project, we will let the users, handle pretty much all of the exporting settings like camera movements. I'll be talking about those in a little. And resolution, quality, also put some timestamps. We didn't get there yet, but so my part was to recreate the small deck component that you see on the screen inside of that UI. So most of the code that Kepler uses to create the big map that you see was reused and modified just to create that small deck component that you see there, using all that scene data that was passed through to using all the Redux stores that Raymond worked on that side. So yeah, we had two big issues that I'm going to talk about next. Okay, there you go. So that we had two canvases, right? And that's not a problem for you guys, just want to show some things. But for us, it is, and let me tell you why. So we had two canvases, the Mapbox and the Deck.gl canvas, all the layers on top, right? So yeah, the map view, oops, in Deck.gl, they work really well with the Mapbox. I mean, they have pretty much the same camera settings like zoom, center, pitch and bearing. So they produce like really consistent results. So you would think they're the same canvas, but they're two different ones on the components, right? And the problem is that Hubble.gl doesn't know that there are two canvases, and it will only export the layers, not the map. I see here on one of the examples. And we needed both. So yeah, that's the first issue that we got. And I'm gonna talk about the other issues, but let me do like a brief intermission. So I'm gonna talk about the cameras and keyframes. So you see here, we have this camera object, we have the timings and keyframes. So keyframes will have the longitudinal zoom that shows the X, Y, and Z. And we have here two of those, but so the thing is that we go from one point to another point in space, but it's not only just like going in the set. It has also pitch and bearing. So it will like calculate all those points in the middle, like create like some kind of curve to get to that other point. So Hubble interpolates all those points and gets to that place. So we had kind of like an issue with that. Let me show you in a second. So remember this screen that you see here. So yeah, the other issue that we found is that was with the view state. So we needed a way first that the user could move inside of that UI component. So before with Hubble, you couldn't do that. You couldn't go there and like change zoom in, zoom out, and just change wherever you wanted to go. But we had to go inside of the Hubble components and change some things. But I'm gonna talk about that in a second. And because the camera was like fixed, as you see the Raymond showed that have like north to south, there's just fixed camera. That we got to the conclusion to use those fixed for the moment, but we needed a way so the user could move around in the component and then use that last view state, that last position, and start the camera there. No, so it could go like from there to whatever they want to go. So yeah, we left in the air the idea of adding some like keyframes inside of that UI component. Like that would be for more advanced users. So they can say, for example, go to 3 points, like 3 cities, for example, and go from this one to this and specify the timing also and the like curve that they want to go and go to the other one. That would be really cool. Like right now we have to only like fix camera from here to here or go from north to south or that. But I think that would be really cool to have like let the user add like more keyframes, let them specify the like I'll go from this longitude to this one and change the zoom or whatever and have several of those. So that's like a more pretentious idea. So yeah. Oh, let me go to the same slide. That's the next one. Okay, so the solutions that we found for the Deck.gl and the Mapbox not being able to, so the GIF layers rendering in one separate canvas over the base maps, and the Hubble only exports one of those. So we used one feature that was launched not recently, I think. That's using the GIF layers as custom Mapbox layers. So according to the documentation, that will enable really seamless interleaving between those two, and it will make them a single canvas. And not only that, because it's just one canvas, they would share the WebGL context, and it would save system resources. That's very cool about that. And yeah, yeah. And you want to kind of know more about that, you can go to the documentation at the bottom and search the Mapbox layers. And the other issue that we found, so we had to modify the Hubble library for that. I mean, I tried to do it from just an example, but it's impossible at the end. So we came up with the idea of having this optional camera function, like method, where you can just, if you have just a Hubble example or a Hubble like project, you can actually use this camera and use the documentation that you can go there and put all those different like methods and insert this view state, or you can see it on the documentation, but it will be simple, and the result will be like this, like you see on screen. So you can go to the position that you want and then have the camera rotate however you want it. So yeah, you see like view state analogy, yeah, saves that last view state and just render whatever you have in screen, like calculates all the points between those two. So yeah, that was my two issues and the solutions that I found. Like, let me go back to Raymond.
Oops, went a bit farther than I wanted. Yeah, so as for the future of this project, you know, this is technically the end of the internship, but both Elisa and I have agreed, as well as Chris, to work on this a bit further, because ultimately we want a goal of being able to integrate into Kepler, kind of like what I was showing earlier, how it had that little export button, so that, you know, all the users of Kepler would be able to create these amazing visualizations just by default. And then additional features I just jokingly put our Kanban board. I'll let you guys see how many more things are on there. It's a good amount. All of these, you know, to-dos and readies that we've got to do. But we accomplished a lot. You know, here's our done section, our ship section. But yeah, there's still a lot to work on. And like I said, we've all agreed to work on this more afterwards. And then an additional thing is, oops, like I was saying earlier, it doesn't work for all of the right now it just works for the TRIPS layers, but you know, there's other types of places where you could export visualizations, and we just need to focus on getting this one working the way we want it, and then we'll integrate it into the other different types of data sets. And then a bit of refactoring, bit of honesty on our end. You know, this was like, it was a kind of an advanced timeline. So some bits of it could be refactored to make it more cleaner. Yeah, I think that's enough said. It's, you know, like I said, we'll be working on it some more, but there were some things that, you know, we did to rush it out so that we could do this presentation today, and those things could be improved upon. But yeah, so here's our details. If you want to follow us on GitHub or connect with us on LinkedIn, I'll leave it on the screen for you guys for a little bit. But basically, the next slide is just if you guys have any questions. So yeah, feel free to ask if you guys have any questions, want some clarification on things.
Well, sweet, good work, guys. This is super cool, super exciting stuff.
Thank you.
So when you clicked on your Kanban board, I saw a little card there for add GIF encoder. So as part of the export, does it currently export into a GIF format, or what all is part of that?
That's I think, well, Elisa, you want to explain it a little bit?
Yeah, it is there, but we didn't add it at the moment of using the dropdown. So it's just added. It's part of the Hubble export, all the encoders that Hubble has. So I don't know how to know. No, it
Yeah,
doesn't.
right now, in terms of like what's supported on our Kepler app, it would just be like these three. But we do have the functionality for GIF. It just needs to be integrated into there.
Yeah, the only thing that we found is that all the the colors in the GIF when it's exported, it's like not bright enough, or it doesn't translate right, all the colors. That will be the only thing. Then I would want to add a small note to let them know, hey, it's not exactly the same. It is the same if you export the PNG sequences or JPEG, but the GIF, it's kind of different. I mean, I think I included some of those on the.
Interesting.
Yeah, so it's almost there. Is basically the TLDR.
All right, that's something that I'm super excited about, and I'm sure Chris knows. I do a lot of presentations, just like making a bunch of slide decks, and so being able to go straight from what I'm looking at to a GIF that I can insert into a slide would make my life many times easier. So that's a feature I'm excited for.
Do you want to add music as well?
Hey, why not? Why not? I had one more question, then I'll let the other guys ask some things as well. So what are your thoughts on chaining together videos? So you have the current like orbit 90 degrees, things like that. What if you were able to do like a rotation to a translate to a zoom out all together in the same video?
Yeah, that's something that code-wise I'd accounted for, but for the purposes of this demo, we just did 2 keyframes just to make it easier. So in the future, that's something we could implement. I'm not sure. We haven't discussed multiple key points too much, but if I would have to guess, it would probably just be like you selecting like start and end point and then another start and end point, and then figuring the transitions between them. But yeah, so like I was saying, code-wise, we've accounted for it, but it just hasn't been implemented, and we didn't discuss how we want to implement it.
Yeah, that was kind of like I was saying, like giving the user, like it can add some say, I don't know if say keyframes to the users, but like small videos, so they can go from like this point to this one and specify this to this, how they want to go to this other point, like zoom in here, then move to this other point, then go to this other. That would need to like add keyframes. That's the thing, how to do it. We talk about that, and yeah, that would be for more like advanced users. So that's just having 2, and it wouldn't be like putting 2 videos together. It would be just going to the other points. Is that what you meant? Like pasting 2 videos or going from?
No. That's kind of our stopgap right now, where like I was saying, I put like earlier instructions on how you can render them and how to like, there's like post-processing tips where essentially, your version of that would be right now exporting 2 videos and combining them in some sort of movie software. But right now we don't have the capability to do it all within the Kepler app.
Got it. Yeah, because tying that back to like what I do, I mean, Uber Air is a multimodal service, meaning that there's like a ground leg and then there's a flight and then there's another ground leg. So it'd be super cool to be able to track all those different segments. So you follow the car, you do like some rotation, you follow the flight, things like that. I think would be super cool to do. But exciting stuff.
That's pretty cool.
All right, I won't take all the time.
No worries. We still got 10 minutes. So any other questions?
I have more of a technical question. The camera presets, how are those defined internally? Like, are you using some kind of matrix math, or is there a library that you've used?
There is a library. It's called Turf. So let me see. I believe it's in the scene.js. Mind the mess, by the way. This is the part of the refactoring. Just cleaning up all the code. It might be in modal. Let me think. Let me see. Turf in here now. Yeah. Okay, it's in here. So basically, when you click on any of the settings, the first thing it'll do is it'll extract the things that you want, the main keywords. Let me think, what is it called? I'm forgetting what the JavaScript regex is. Yeah, so it'll abstract the keywords. So for example, it'll get orbit and then 90. And then with Turf, it's a library. Actually, let me step back a bit. Turf is used mainly for these ones. The rest are with the like you were saying, the orbit. That would be with the Hubble library. So, but north to south, for example, that would be done. Those sorts of translations would be done with Turf. Essentially, the parameters for Turf is like, you know, here's your input, and then how many kilometers or miles do you want away from it, from that point, in what direction.
Oh, that's pretty cool. Is Turf an external library?
It is.
That built within like
Here it is.
GL or Hubble?
Yeah. So here's like what I was saying, the parse camera. So just doing a regex match, and it'll get like your keywords, like I was saying, orbit 90. And this is what I was talking about. We did account, this would work for multiple keyframes. So that part of the code base has been thought of beforehand. But yeah, so Turf is essentially, it'll translate your GeoJSON object to essentially like a lat long. So it'll just be like, oh, okay, here's the points I want. Now Hubble, move it to this new set of lat longitude coordinates. That's how it does the, you know, the east to west, north to south, et cetera, et cetera.
Oh, that's pretty neat. Is Turf an external library, or is that something that's built within?
Yeah, it's called Turf.js.
Turf.js. I'll have to check it out.
Turf.js.org has all that stuff. It's a JavaScript set of JavaScript geospatial utilities.
And Hubble itself has the rotations, like the orbiting and whatnot.
Yeah, a little above this, he has the bearing code, where it basically just sets. You can see right there on second keyframe on line 415, I think, 416, takes the second keyframe and changes the bearing from kind of whatever your initial condition was, which I think is bearing 0, to whatever you want it to be, like bearing 90 or 60.
Yeah, so like I was saying, it'll get like orbit from 90 or something. And that's what this match one would be. The first part would be looking for what's in the first array, and yeah, then it's changing your bearing.
Cool stuff.
Thank you. Any other questions?
So what's next for you two, actually? I kind of was curious.
Yeah, so like I was saying, I graduate literally tomorrow. So it's gonna be, you know, a little bit of a break today, and then going back to applying to jobs, grinding out leak code, applying to some Uber positions, you know.
Yeah, and for me, we just continue until I finish. But yeah, I have like 2 more years of school to get through. But I do want to continue this project. It's open source, so until, I don't know, I can get to put it on Kepler, and maybe in the future go to the other like layers they have. It's interesting.
Yeah, definitely a good resume piece. Just like, oh, shipped out this feature to however many, I don't think we ever got a number as to how many people use Kepler. I looked and it said something like 50,000 on like SimilarWeb, but those aren't usually too accurate, just like a guesstimate. But yeah, it'd be good to put on the resume.
What was your guys' favorite part of the internship?
Favorite part? Well, like I said, I came in here wanting to level up as a software engineer, and like this has pretty much been what I wanted. Just having to learn so many different libraries. I think it would be great practice for when I get that software engineering position. But in terms of favorite parts, I kind of like the way that I did this, like technically. Just I thought it was like the way that we had it before, it was essentially just like a whole bunch of if-else statements. I'm like, no, it's not going to work. I need to refactor this. So essentially, I made it more scalable to where it just gets like, it parses the keywords that I want. And there's even options for like, you know, if we want to, right now it's like north to south, for instance. But what if we wanted north to east or east to north, something that's not there? And this will account for that. So that's definitely technically my favorite part.
Well, mine in terms of like team, yeah, work in the team, and having meetings pretty much every week. And I really like the cards that you saw, the project that will let us all be in touch with what we're all doing. And but technically, what I liked the most was to like, get that scene data and try to build the small scene that you see in the middle. So
Oh, the modal, in terms of the modal?
Yeah.
Talking about, yeah, this part.
Yes, that. And yeah, I had to also get I had to go into the basic controls from Hubble and pull a lot of code from a bunch of different places to get to the encoders to work. And yeah, I really like that, work with that such big code base and see results. Like, usually you just work and you don't see it, but this is a visualization. You can see pretty immediately what you're doing. And actually I have an like a story, and I'm not sure it was this project or what, but it broke my last laptop. It didn't work at all. So I had in my mind getting another laptop, but actually I had to at the end. So yeah, I had to get another one better with a better graphics card. It is different when you have everything already, that when you're working and it suddenly creates like a bunch of canvases and you don't know why, your computer freezes and everything breaks. But
Yeah, that's actually something similar that happened to me. Well, it's because I have to take in this MacBook for warranty because of that keyboard issue. So whenever I do Slack messages, there's gonna be like random typos because like my keyboard pressed like 2 or 3 times or something. So I have to send it in. So I tried to like get all this working on a Raspberry Pi, and that did not work well. There's like too much graphics power needed for a Raspberry Pi. So I've still got this, and pretty much after this internship, I'm gonna warranty it.
So what you're saying is that Chris broke your guys' laptops.
I'm
Yeah,
sorry.
he does. He owes us like a referral code or to Uber or something.
My favorite part of all this was just working with you too. It's really great to basically have a team to work with on Hubble. I've gotten a chance to work on it with people internally here, and that's been a blast. But working with some completely fresh faces, like I was really interested to see how this would all go. And honestly, this is my first time really running a small team outside of like I don't manage anyone, so it was really fun for me to get to know you two and kind of figure out how to set a team up and work together. So thanks for coming along the ride for so long. This was also, I don't know if we mentioned it, this was meant to be 4 weeks originally. Well, for Raymond, it then turned to be 12 weeks because of a graduation requirement. And then Elisas just decided to stay on for the whole time. So I guess something was working because it ended up tripling in size from like the original time commitment.
That's awesome. That's awesome. Well, it sounds like it was a super fun project. You guys did some great work. I mean, the demos show it. So I'm super excited to get to use this stuff that you guys are putting out there. And yeah, so keep up the great work.
Thanks.
Good luck in school. Good luck in the job search.
Yeah.
Yeah. Thanks for the presentation, guys.
Definitely. Yeah. Just next step for this is like, minor bug fixes, but I think we're pretty close to ready to being able to show this to, was it Shan?
Yeah, Shan.
Was that she's the main Kepler.
Mm-hmm.
We need to set up like a meeting and she needs to like look over the code and we need to help her. But yeah, I'd say it's like mostly there in terms of like getting that Kepler feature.
It's awesome.
Good work. Thank you.
All right. Thank you guys for coming.
Thanks for joining us.
Yeah.
Awesome. Thanks, guys.